In this question, we're asked to determine the molecular speed distributions based on temperature and molar mass. So in the first sample, the first box that we're going to choose, we have 3 samples of xenon. And all that matters here is, because they're all xenon, all that matters here is the temperature. So A is moving the fastest on average, followed by B, followed by C, because A is at the highest temperature and C is at the lowest temperature. Now we want to pick the graph that depicts that. Notice that in these graphs, for probability, these like have nodes in them. This is something that's important if we're looking at electron behavior, but when we're looking at speeds of gases, you're not going to see any kind of graph that looks like this. It needs to look like this. The distributions need to look like this. So we can skip this one. Now let's look at this one. Here, B is moving on average the slowest, so it should be at the lowest temperature. Note that B is not at the lowest temperature, so this is not the correct graph. Here, A is moving on average the slowest, so it should be at the lowest temperature. Note that A is at the highest temperature, so this can't be the right graph. Here, C is moving at the lowest temperature and is moving at on average the lowest speed because of the peak of the graph is furthest to the left on the speed axis, followed by B, which is the next lowest temperature, followed by A, which is the highest temperature. So this is the correct graph. Now let's look at this other example. In this case, the temperature is constant, but the identity of the gases is different. So here we have argon, which is the lightest, and therefore will move the fastest, followed by krypton, followed by xenon, which is the heaviest, and therefore will move the slowest. So we need a graph with these type of peak shapes where F comes first, because F is going to be the lowest speed because it has the highest molar mass. Remember that you read the average from the top of the peaks. I'm kind of ignoring the rest of the peak, although they do spread out, which is important for other things. This doesn't quite make any sense because D argon is moving the slowest, which doesn't make sense because it's the lightest. This is not this shaped graph, so we can just ignore it. Here we have an example of F, which is xenon moving the slowest, followed by E, which is krypton moving the second slowest, followed by argon, the smallest molecule, which is moving the fastest, and this is the correct answer.